In this presentation, what we are going to do is, this is partial differential equations. It's very introductory level stuff. Essentially, what we're, the main part here is to sort of getting the building blocks of the basics of differentiation sorted out. Show that the function z equals e to the minus 2y cos times cos of 2x satisfies the partial differential equation. The second differential of z with respect to x and y, d2z over dx squared plus d2z over dy squared equals 0. Okay, so what we're going to do here is we will break it up into two parts. So this is the first part, and what we're going to do here is work with respect to x. Okay, everything that's taking place here is we're working with respect to x. So first off, what we're going to do here is get the derivative of this expression here with respect to x. Now we're going to break it up into two parts. E to the minus 2y doesn't have any x terms in it. It's not an expression in terms of x. So we're actually going to be able to sort of bring this through the whole way down and just leave it there as is. Okay. Now, cos of 2x. Be very careful about this one. In general, cos of x, we would differentiate that as minus sine of x. Okay? But when you have a sort of constant term here, cos of a of x, where a is some constant, you have sine of ax, but you also multiply the expression by a also. So you have the minus, because it's going from cos to sine, and you have that that constant term. Okay? So watch out for that. Just make sure you have this sort of practiced properly. So this is minus 2. So it's minus, or actually just because, okay, cos is, when we differentiate that, becomes sine, okay, or minus sine. And because we have 2x here, we put in a 2x here and a 2 here. Okay? Now, that's quite important. Now, what I'm going to do here is I'm going to sort of tidy up this into one expression. So I'm going to put the minus 2 down here. And what I'm going to do is just differentiate that part there, sine of 2x. Now, it's something similar here, except you don't have to. The sine to cos is, when you differentiate sine of x, it's just cos of x. So when we differentiate sine of 2x, what we get is 2 times cos of 2x. Okay? So just to be clear, the sine of 2x gives us this part here, 2 cos 2 of x. Okay? This minus 2 I brought down over here, and the minus 2y was just brought down the whole way through. So anyway, when we tidy that up, I'll just put this in blue pen here. That is minus 4 times e to the minus 2y times cos of 2x. That's the overall answer for this term here. Okay, so that's the first term completely sorted out. And again, I'll just write it in there again. Second derivative of z with respect to x. There we go. So, the next thing we are going to do is do this with respect to y. Okay? So what I have here is, let's just write out the expression again. This is just some leftovers from a previous presentation. Let's do this in black pen. Okay. So the expression here is e to the minus 2y cos of 2x. Okay. Now, what we're going to do again is split our expression up into two. Now, the cos 2x part, we don't do anything with. We just bring it down the whole way through each time. Cos of 2x. Okay? Because it's not an expression in terms of y. Now, in general, when e to the y, or okay, e to the y here, if we were to differentiate that with respect to y, it's just e to the y. But if we were differentiate it with respect to y when it has a constant term in front of the y, then we get a times e to the y, ay. Okay? So it's something very similar to that constant term I mentioned on the last page. Okay, so what we have here is minus 2 times e to the minus 2y. So you bring down that minus 2 also, and you have the minus 2y. And we'll do that again. Essentially, all we have to do is differentiate this bit again. Okay, the minus 2 can come down now on its own, because it's a constant, but it's the differential of e to the minus 2y, and again that is minus 2 times e to the minus 2y, okay? The minus 2 times minus 2, we can simplify that, and we can have 4 there, okay? So the overall answer is 4 times e to the minus 2y cos of 2x, okay? So let's put this all together, and what we have here is the first term here is d squared x over dx squared, and we found that to be minus 4 times e to the minus 2y cos of 2x plus 4, so this is the second expression, e to the minus 2y cos of 2x. So essentially what we have is this term here plus this term here, okay? Essentially, this term here, essentially they're identical. It's just plus a 1 minus the other, so essentially they both cancel out, and we left with 0. Okay, so that identity that we seen at the start holds, and it's also up there. Okay, that's the end of this presentation.